none of my roommates are home, so I'm going to have to film this one myself. My name is Micah Richardson, and this is my concept map. We'll go ahead and come down here and start it. At the top we have inorganic chemistry, which is just a general term for chemistry. You get a little more specific with organic chemistry, which is the study of mainly carbon compounds, which is why it's starred, and it also has some concepts we'll go over here and look at. In organic chemistry, we have what's called functional groups, and they are connected to carbon chains. If you look over here, we have two of these main functional groups, amino and hydroxyl, which when they come together, they form amino acids. And amino acids are the building blocks for protein, which is one of the four main building blocks of life and organic molecules, including nucleic acid, carbohydrates, and lipids. You can see that nucleic acids are made of nucleotides, proteins are made of amino acids, lipids are made of fatty acids, carbohydrates are made of sugars, and if you combine a protein and a carbohydrate, you get a glycoprotein. And if you combine a carbohydrate and a lipid, you get glycolipids. Over here, we'll see that we have these little subsets of carbohydrates called polysaccharides and monosaccharides. And then if you look up here, we have saturated fats and unsaturated fats, which are different types of lipids, having to do with the amount of hydrogens. And also right here, you can see that if you combine lipids and glycerol, you get what's called a phospholipid. Okay, back to the main one. In this orange cloud, we have some of the main elements we study in organic chemistry. And an element is made up of atoms, which are the smallest particles of life. Over here we have a couple little side thoughts that have to do with their connecting concepts. An isomer is essentially the same amount of atoms and molecular formula, but they're just arranged a little differently. And then we have the two different isotopes, and an isotope is just an atom arranged differently. If you come down, you can see that an atom is made up of nucleus and electron shells. We'll start over here with the nucleus. It's the center of the atom, and inside of it we have protons and neutrons. Protons are positively charged and neutrons are negatively charged. And combined, they sum up to be the atomic weight, which is the weight of the atom. Over here you can see we have another side note right here. The amount of protons in an atom is its atomic number. We'll go back down here to atomic weight. We have a side note down here, it's called molecular weight, and that's just the combination of all the atomic weights of each element in a compound. So an atomic weight is measured by what's called a Dalton, which is just moles or grams per mole. And over here you see moles are also important in what's called molarity, which is the liters per mole. It measures the amount of a solute in a solvent. And over here we have a side note, it's called milliliters. It's another measurement. It's just a 1,000th of a liter. So we'll come back over here, and you see that we have the electron shells, which is the outer shells of the atoms, and they house what's called electrons. Over here, here's another little side note, electronegativity. It's the tendency for an atom to want to attract electrons. And we see over here, I'll take you from the electron shells over to what's called valence electrons, which are the specific electrons in the electron shells. They're on the outer shell, and they're what are readily available for sharing or taking or giving up. And with valence electrons, you have two concepts right here. You have an ionic bond and a covalent bond. An ionic bond is a bond where they are not shared, they are taken completely, and a covalent bond is where they are shared. And along with covalent bonds, you have 4 different types of covalent bonds. You have a double bond, which is 2 electron pairs shared instead of just one. You have a triple bond, which is 3 electron pairs shared instead of just 1 or 2. And you have a polar bond, and you have a nonpolar bond. The difference between a polar bond and a nonpolar bond are a nonpolar is an equal sharing of electrons, and a polar bond is an unequal share of electrons. So we'll come back over here to electrons. You go down and you see this thing called redox reactions. It's a concept that has to do with the transfer of electrons between 2 species. And they deal with what's called electron donors and electron acceptors. Electron donors are readily available to give away electrons, and electron acceptors are readily available to accept electrons. Examples of those are bases for an electron donor and acids for an electron acceptor. Bases are typically anions, which means they are negatively charged ions, and that's why they're ready to give away their electrons, because they have plenty. To become neutral, they can give away an electron. An acid is normally a cation, which means it's a positively charged ion, which is why it's readily available, because to become neutral, you need an electron. The base and the acid, when they combine in a redox reaction and they become neutralized, they form what's called a salt. An example of a cation is, specifically for acid, is the hydrogen ion. This is the most common seen one, and when combined with water, they form what's called a hydrogen bond. A hydrogen bond is an example of cohesion, which is the act of like molecules sticking together. So when you come over here, you have a little side note. It's called adhesion, which is just the opposite of cohesion. It's unlike molecules sticking together. The hydrogen bond and the water form what's called a hydrogen bond network of water, which is just the bond of the hydrogens that make it easy for water to change phases because they're easily broken off. Hydrogen and water together form a hydronium ion, which is H3O+. And here's a little side note. We have that hydrophobic interaction is connected to water. It means interactions between 2 nonpolar molecules in a polar solvent. And that is my concept map.